if we want to overcome the problems in reverse bias, is we change the diode. Rather than we use the normal diode which cannot be operated in reverse bias, now we can use the Zener diode. Okay, still diode but then different characteristic lah. The Zener diode, the symbol is macam ni. So dia lain sikit. Dia ada it has this one kat sini. Okay, if you come across this such of symbol, then this is Zener diode. Okay, the special diodes. It is not the normal diode. Yes? Why? Duduk dekat ni. Baju merah sini je. Ambil, take this chair. Okay. Alright, so this is for the Zener diode. Okay, now we want to compare between the normal diode with the Zener diode. Okay, the normal diode can conduct current in one direction, kan, only in forward bias. But then for the Zener diode, we can have both, for both direction. Okay, if you go dekat sini tadi, okay, in the regulator, we have the Zener diode. So we use the Zener diode normally dekat at the end of the block diagram. Okay, and this is the output yang kita nak. Meaning that Zener diode is the components that can be used in order to ensure that the current yang kita dapat ataupun the supply yang kita dapat from this block diagram is safe to use. So that bila kita guna from the adapter ataupun charger contohnya, bila kita connect to our devices, dia takkan reverse bias. So kalau if that conditions problems occur, might be sama ada the circuits dalam voltage regulator tu rosak ataupun our devices might be damaged. Okay, so that is very important. Yang dekat hujung sini we use the Zener diode. Okay. Okay, normal diode might be damaged if we have large reverse current, but then for the Zener diode, it will be safe to use. But then until certain amount only. Okay, not until, tak adalah sampai 100 minus 100 minus 100 ampere still okay. No, it is until certain amount. If you tengok on the IV characteristic that I have shared before this, we have, this is for Zener. Katakanlah for Zener, kan, dia ada for silicon. For the silicon, what is the value for IV characteristic? 0.7. Okay, if it is for germanium, 0.3. Okay, for the Zener, if we use silicon type, it is 0.7 here, but then this one is 6.3. Okay, 6.3 is for the avalanche value. And then kat sini is 5. This is minus lah because this one is negative region, kan. Okay. Normally until certain amount dia tetap akan rosak juga. Okay. If the question require you to draw the IV characteristic for the Zener diode, so you lukis this one. Okay, this is the IV characteristic for the Zener diode. Okay, how to get the Zener diode? Because the Zener diode is different from the normal diode. It is actually from the same process. What is the process? Doping process. We add the element of P or N. It is either P ataupun N lah. Okay, in the what is the semiconductor? The original form. Semiconductor yang original, yang without the doping process lagi. Cepat Zul. Apa? No, opposite of that. Yes. Intrinsic. Kalau you nak ingat in dalam. Maksudnya in is the pure form. Yes. What is your name? Firdaus. Okay, Firdaus, selamat sebab dia dah WhatsApp. Okay. Alright. So dia WhatsApp saya 7:15. So you dari mana?
Dari Bandar Sarjana Putra.
Oh, 7:15 dah jam kat sana.
Patutnya kena keluar 6 setengah, saya bangun lambat.
Okay. Alright. So dia dah tahu dia terlambat and then dia dah WhatsApp saya. So saya tak adalah query kenapa. Okay. So please have a seat. Okay. So extrinsic is the semiconductor that we already have 4-range element. We have intrinsic. Okay. Intrinsic ni dia macam introvert. Okay. So we add some 4-range element. Kita tambah benda asing. It will become extrinsic. Extrovert. Dia suka benda luar. Okay. So how to get the Zener diode? If we have one normal diode, we have certain amount of ratio lah. Kalau nak jadi extrinsic normal diode, kita kena tambah, contohnya P nak tambah 50-50 ratio, the ratio. Dia adalah certain formula of the ratio. But then if we want to get the Zener diode, dia punya formula will be different. Okay, dia tak sama on the normal diode formula lagi. Okay, yang tu kita tak belajar lah for the materials. Okay, so that is how to get on the Zener diode. Sama same process, tapi on the apa yang kita tambah in the doping process tu might be different. Okay. For the normal diode we use in the rectifier circuit, but then for the Zener diode we apply in the voltage regulator. Here lah. Okay. Rectifier kat sini normal diode. Okay, for regulator we use the Zener diode in the circuit. Okay, so this one yang saya lukis the IV characteristic of the Zener diode. Okay, the question might ask you to draw the IV characteristic of the Zener diode. So you should draw this one lah. Okay. This is the label, the symbol for the diodes, the Zener diode. The beza sikit this one. Kalau normal diode only satu straight je Okay. Yang atas tu pun boleh for the this one. Dia ada beza hujung tu je lah. Okay, for the Zener diode. Okay. For the Zener diode, kalau kita tengok in here, this is the breakdown region. Okay, breakdown meaning that reverse. The current is reverse. Okay. So, this is when we use germanium. Ini kalau guna silicon. Okay. For the breakdown region, we have two types of breakdown for the Zener. Okay, we have the Zener breakdown and avalanche breakdown. Okay, for the Zener breakdown, let's say if we have this is the PN junction. Okay, kat tengah we have the depletion region tadi kan. Okay, and in the reverse bias, we have the depletion region lah from P to the N. Okay, this one is the depletion ataupun space charge region kan. Okay. Okay, so for the reverse bias in Zener breakdown condition, we have the depletion. Kalau forward dia tak ada space charge kat atas kan, kat tengah kan. Kalau forward bias from P dengan N, kat tengah ni is only one single junction. We don't have the charge kat tengah kan. Okay, I hope that you guys still remember lah this one. Okay, if it is forward bias, the line kat tengah tu dia nipis je. Okay, because we don't have charge kat situ, the other charge akan tertarik dekat tepi here. Okay, this is for forward bias. Okay, for the reverse bias, for Zener breakdown, we have this depletion region. Kat tengah is all the charges that attract. Kalau P, they will attract to the P is positive. Positive will attract to the negative side. For the negative, we attract to the positive side. So for the Zener breakdown, it is due to the movements of the carrier. Okay, meaning that from the electrons from N will attract to the P side. So dia akan bergerak. Okay, that one is akan induce the Zener breakdown. Okay, for the Zener breakdown, dia dekat sini. Okay, I change my pen. Dia dekat sini. Around 5. Okay, so dia akan occur Zener breakdown dulu. Okay. Okay, we heavily dope the semiconductor. Bila kita tambah P dengan N in the semiconductor, automatically dia akan attract lah from the one side to the other side. Okay, from the majority carrier, P attract to the minority carrier dekat N. Okay. Okay, this one. Okay, for the Zener breakdown, dia akan jumpa the Zener breakdown dulu. Okay, this is might be around 5 lebih kurang. Okay, this is due to the movements of the ions. Okay, kalau you baca dekat sini the explanations macam mana boleh dapat movements of the ion due to the doping lah. Bila kita tambah P dengan N, dia akan jadi apa. Okay, so that is for the Zener breakdown. After the Zener breakdown, if we further increase the reverse bias condition, kita increasekan lagi. Contohnya daripada minus 10, kita jadikan minus 20. What will happen is, dia akan occur lagi satu condition, we call it as the avalanche breakdown. This one is around 6.3 macam tu. Okay, for the avalanche breakdown, reverse breakdown, more than 5. Okay, for the avalanche breakdown, this is due to the collisions of the ions. Kalau tadi in the Zener, ions dah bergerak kan? Okay, ions dah bergerak. What will happen when all the ions dia excited and then dia berlanggar? Okay, vibrate. Okay, dia tak ada certain macam highway, dia dah ada laluan kan? Okay, you imagine the crash car. Kau orang panggil apa kereta langgar tu? Bukan. Tentang bau. Bubble car. So yang dekat circus ke apa? Funfair. So dia main langgar-langgar je. Once lagi banyak langgar, so dia akan langgar orang ni, bounce langgar orang sebelah. Bounce. So that is happen dekat sini. But then this is ions yang kecil. Okay, so dia akan langgar. Mula-mula dia akan bergerak. Bila dia banyak bergerak, so dia akan banyak berlanggar. So the Zener breakdown is due to the movements. Okay, for the avalanche breakdown due to the collisions. How to get the collisions? Kinetic energy lah. Okay, so dia due to the collisions of the ions. Okay, so dia akan further decrease.
Collision tu is antara positive and negative ions.
Normally between the kalau positive and negative dia attract terus. Dia tak collide. Normally dalam same concentration. Maksudnya kalau positif dengan positif dia berlanggar. Okay, contohnya nak lumba, semua nak pergi one side, tapi semua nak menuju yang sama. So might be dia akan sama-sama terlanggar lah. Okay, so that is for the avalanche breakdown. Okay, if the positive and negative bila berlanggar dia terus cantum je, dia tak bounce balik kan? Okay, so that is for avalanche breakdown. Kalau beza on the Zener is the movements, avalanche is the collision. Okay, avalanche breakdown. Okay, so this is for the avalanche breakdown. Okay, pergi sini dulu. This is for the Zener breakdown. If you go for the depression region kat sini, it is narrow. Okay, but then if we further decrease the value, if we further go for the reverse bias or reverse voltage, dia akan jadi wider. Okay, bila lagi wider, maksudnya collisions akan lagi banyaklah berlaku. Okay, but until certain amount only. Sampai one amount, dia akan rosak juga for the Zener diode. Okay, so this is very important to study. Contohnya we want to design a system, tapi we want to until certain value, after that dia tak boleh lalu, so dia akan rosak juga, ataupun dia terus off. Okay, dia terus off juga the diodes. Okay, so now for this chapter 2D, we will do the calculations on what is the value that allowed to go through atau to pass in the Zener diode. Okay, until certain amount it is not safe to be operated, or further, if we further use, dia akan break down dan damage the Zener diode. Okay, so itu sahaja on the theory sebenarnya. Okay, I just explain what is avalanche, what is Zener. You guys boleh baca this one, saya dah tambah few informations. And this is on the voltage regulator circuit. This is actually for this circuit, for the Zener, we apply in the voltage regulator. This is actually simple circuit like this. Kalau saya lukis balik, this is RS. This one is the Zener. Okay, and here we have the R load. Okay, VS, the supply. Ni circuit yang sama This is the same circuit. This one in voltage regulator. Okay, we apply in the voltage regulator. So we have the IS here. We have the IZ because this is Zener, so we call it as the IZ. We have the IL in the RL. Okay, so if we do the KCL, how to do the KCL? IS equals to IZ plus IL. Yes, this is the KVL. Okay, if we have the VZ from here to here, we have the VL kat sini pula. So what is the value of VZ and VL? If I said this is point A, bawah is point B. So VAB equals to Is it VAB equals to VS? Kat sini, this is A, this is B. Sama ke? VAB equals to VS ke? VZ equals to VL. Nampak tak? This is same node. So VZ must be equal to VL. Okay. So VS equals to VRS plus VL. Ataupun VRS plus VZ. Sama kan? If we do the KVL, minus VS plus VRS plus VL equals to 0. So you dapatlah this one if you tukar. Okay, this is the KVL. Okay, this one is the from the KVLs juga. Alright. Okay, so this is the concept for the Zener diode in the voltage regulator. Okay, you guys boleh baca. Okay, this one is a voltage regulator efficiency. Since this one hujung, we have the variable resistor. So for the variable resistor, we will have the minimum value and maximum value. Okay. Variable resistor is the resistor that we can vary. Okay. So if we want to get the efficiency of the voltage regulator, we know load ataupun we at the minimum load, or when there is minimum load ataupun there is no load at all. Okay. Minus we full load. This is the maximum value of the voltage. This is over the maximum value. Okay. And all of this multiply with the 100. Okay. To get the efficiency of the voltage regulator. Okay. Kalau we full load minus we full load over we full load, dia akan dapat 0 kan. Okay. Okay, so now we want to go for the... This is another explanation. Tak ada apa. Zener diode is a diode that allows current to flow in reverse direction. Okay. Okay, for the calculations for the Zener diodes, we have three types of three conditions for the calculations. Okay, three conditions. The first one is this. Kalau for the Zener diode, circuit dia memang macam ni je. Okay, this is boleh juga kalau nak lukis macam ni, benda yang sama je, the supply. Okay, this circuit is memang macam ni sahaja. Okay, we have three conditions. First is we have fixed VI ataupun VS, the supply is fixed, but then we vary the RL, the load. Okay, when we vary the load, might be dia akan lukis macam ni lah. Okay, akan ada variable resistor. This is the first condition. The second condition is we fix the supply, but then we vary, tersalah dah. Okay, if for the first one, dia akan lukis macam ni lah, because fix for both kan. Okay, fix for VI and the RL. For the second one is the vary. This one baru kita ada variable resistor. So dia akan jadi ada RL min and RL max, because we will have a certain range for variable resistor. When we have the RL min, automatic kita akan ada IL kan. So IL max When RL max, IL min. Kenapa dia satu min, satu max? Because I equals to V over R. If the I is maximum, R is minimum. Because this is inversely proportional. Okay, satu akan besar, satu akan kecil. Okay, so that is for vary the variable resistor. The third condition is we have the vary supply and fixed on the load. This one we will have VI min and VI max. Okay, when we have the VI min and VI max, apa yang akan kena ada min and max juga is this I. Dia tulis I ke? Ikut sometimes dia tulis IS because kalau dia bagi VS. So sama je. Okay, so if we have the VI min, kita akan ada I min. Okay, this one kita akan ada I max. I dekat this resistor R. Okay, so this is when we have vary supply but then fixed on the load. Okay, and for the Zener characteristic also, sometimes dia boleh bagi the value of P dalam Zener. Kalau dia bagi value of P, dia akan bagi value kat sini lah, contohnya 500 watt ataupun milliwatt. So dia akan straight away bagi in the circuit. Okay, so for that one, if it is given the power, you can use to get the IZM ataupun IZ max. IZM is equals to IZ max. Okay, meaning that this is the Zener diode current maximum value can allows to flow in the Zener diode. Kalau lebih daripada tu, the diodes might be destroyed juga. Okay, so for these calculations, we need to determine what is the value that acceptable to flow. Okay. Okay, first we go for the fixed for both supply and the diodes. Supply and the resistor lah. Okay, so this one normally dia akan circuit dia macam ni je. Dia tak akan ada circuit yang pusing-pusing. Okay, this is the supply. We have the supply, we have the R, we have the Zener diode, we have the RL. Okay, so first thing is, for the first condition, we need to determine the diode is on or off. Because kita akan ada dua value. We have the value of VZ, we also will have the value of VL. First thing is, we need to determine diode is on or off. Okay, how to determine is, kita buat removing, first is kita assume to remove the diode dulu. Okay, because we want to kira the VZ dengan VL. Okay, so this one, let's say if VZ so sama dengan VL, this is for current divider formula. RL over R total multiply with the V supply. VL. Sama kan? Okay, so if we get the value, first thing is you need to determine either it is on or off. So if we get the value, less than VZ, normally the VZ, this one, dia akan given. Kau dah nak letak 10 ke 8 ke, depends on the circuit. Okay, if we kira tiba-tiba you dapat less than VZ, maksudnya you kira the VL here, if it is less than VZ here, meaning that the diode is off. When the diode is off, maksudnya there is no current IZ. So when there is no IZ, IR equals to 0. IZ is 0. IR equals to II equals to IL. Okay, because the IZ is 0. Okay, the second condition if V is greater than VZ. Bila kira-kira VL ni lagi besar dari VZ given. Let's say you kira VL dapat 12, VZ is 10. So we conclude the diode is on. When the diode is on, we have the value of IZ. So IR equals to Z plus IL. Okay, so we can proceed to kira, to measure, to calculate the value of IZ. Kalau tadi IZ tak perlu kira because it is 0. Okay. Alright. So next one, bolehlah nak guna method mana-mana yang kita dah belajar. Okay. Tadi kita dah ada VL. Just now once it is on, so we use the value of VL. Okay. So IL is equals to VL. IL equals to VL over RL. Normal biasa. IR is VR over this one. VR kat sini. Okay. IR is equals to VR over R. But what is the value of VR? Kat sini is VI. Here is VL. Because kat sini VL. Same note. So the value of VR is VI minus VL. Minus VS VI plus VR plus VL equals to 0. This is KVL. Okay. So this one given, VL pun dah ada, so we can get the VR. Sebab tu masuk dekat sini. Okay, so you can get the value of IR. Tadi dah dapat IL. Next one, you can get the IZ lah. IR minus IL. Okay, you can get the value of IZ. Okay, once you dapat the value of IZ, normally if the PZ is given, this is kalau dia bagi PZM, so we can get the IZM. Okay, if it is given the PZM, so we can get the IZM. So if the diode current yang kita kira is less than the IZM, because IZM is the maximum Zener diode can flow. If it is less, so it is safe to operate. If it is more than that, it is not safe to operate. Okay. Okay, so we have one example here. Okay, first thing is need to determine the diode on or off. Okay, we need to determine the diode. It is either on or off. Let's change the value. Kita tukar the value. For 16 kita jadikan 20, 1K jadikan 2K. I'm not sure jawapan dia dapat berapa. This one jadikan 1K. What else yang ada? Okay, this one lah. 16 jadi 20, 2K, 1K. Okay, yang lain tu maintain sama. Dapat tak? First thing is determine the diode is on or off. What is the value of VL? What is the value of VL? 6. Berapa? Mana attendance? Ada dapat berapa? Belum start lagi. Apa nama? Ha? What is your name? Dimitri, dapat berapa? Dapat berapa? What is the value of P L? 6 point? Alah, off jugalah kan? Okay, 6.67 eh? Okay, 6.67. So, what is the condition of the diode? The diode is off. Okay, so if the diode is off, yang lain tu you guys boleh kira lah kan. So, I want to get the value for the diode is on. Berapa kita nak tukar resistor jadi berapa untuk diode jadi on? Boleh someone try? Try and error. Increase the resistor jadikan 4 ke? Tengok. Resistor RL. Resistor RL. Increase the RL. First is okay, if we change the RL to 4 dapat tak? Dapat berapa? So it is on. Okay. So the second one, change the resistor to 4K. Okay, and then you can proceed because the condition is on. Okay. Point berapa dapat Nadira? Bukan Nadira, siapa nama? Hani. 14 point? 13.33 Okay, you will get the V equals to 13.33. Okay, so it is on. Okay, if it is on, kat sini lah. So dia akan jadi 13.33 volt. So the diode is on. Okay, sorry. But then once the diode is on, we proceed with the given VZ value because diode is on. Kat mana tadi saya tulis kita guna value IL tu? Tak ingat. Okay, once the diode is on, so the value 13.33 ni is just to determine the diode is on ataupun off. Okay, once you get the value of this one VL, we need to use the value of the given VZ value. The given VZ value. Okay, tadi ada saya tulis guna VL kan? Salah kat situ. Okay, because now kita dah tahu the diode is on. So kita akan guna this VZ. Meaning that kat sini dia akan jadi V equals to 10 lah. VZ tadi kita tukar jadi? Oh, kita tak tukar kan? Okay, so kita tak tukar. So you just maintain the VZ is equals to 10. So for the rest nanti you tukar. The RL tadi dah jadi 4 kan? Betul tak? Okay, so VR will be 20 minus VR will be 20 minus 10. So it is 10 kan? Okay. So you can get the IR lah. IR 10 over R kita is 2K. Okay, siapa yang tak boleh follow bagi tahu IR is 10 over 2K will be dapat berapa? You kira lah. 5 milli. Kan? 5 milli kan? 5 milli ampere. Okay. So IR is 5. IL 10. IL VL is equals to VZ. Kita tak pakai dah 13 tadi tu. This 13 is only to determine the diode condition saja. Alright. Once we already get the conditions of the diode, it is on. So terus kita pakai the VZ given in the Zener diode. Okay. So now we use the VZ equals to VL. Berapa tadi? 10 kan, kita tak tukar. So 10 over the RL. RL kita is 4K. So it is 4 milli, right? Bukan 0.25 ke? 2.5 milli.
2.5 milli.
Okay, so IL is 2.5 milliampere. Okay. Once dah dapat the IL, dah dapat IR, so now we can get the IZ lah. Kan? So the IZ will be 5 milli minus 2.5 milli. So you get 2.5 milli juga. Okay. It is 2.5 milli. Ada tak yang tak faham? Ha? Tak faham? IL? Okay, kat mana tak faham? VL? Okay, once kita dah dapat 13.33, kita tak pakai the value untuk calculation. 13.33 kita cari untuk determine diode tu on ataupun off. Sebab kita ada VZ given dalam Zener diode ni. Macam bila kita ada satu component, dia dah ada datang data sheet dia, value dia berapa. Tapi kita tak boleh nak straight away guna sebab kita nak determine on ataupun off dulu. So that is why kita buat voltage divider tu, yang RL over R1 plus RL darab dengan sepelan. So dah dapat 13, kan? So once you dapat the 13, the VL is equals 13. VZ given is 10. VZ is 10. Dekat diode. So 13 dengan 10 dia parallel. Sepatutnya dia kena dapat value yang sama. Tetapi so kita nak pakai value yang mana? Sebab dia tak tally dengan konsep parallel. Okay, so jadi the 13 tu untuk determine condition sahaja. So to proceed with the calculations, kita guna value of the VZ given 10 tu. Okay, value of Z given kat dalam this one, yang dia given tu lah. Tak kira lah 10 ke 12 ke, because sini kita dapat 13, sini dia bagi 10. So dia macam tak tally kan. Patutnya dia kena dapat dia value yang sama. So kita the 13 value, 13 volt tu is to determine condition of the diode saja. Once diode on, kita guna value 10. Okay, maksudnya kita guna value as 10. So when we assume 10 here, so we can get the IL. Because this is 10, IL is equals to 10 over apa Arif? 10 over 4K lah, 10 over RL. IL equals to voltage VL over RL. Tapi VL tu bukan yang 13 tadi. Bukan, because just to determine diode on ataupun off. Kalau diode off, yes, dia 13 lah sebab sini tak ada. Kalau diode on, pakai value diode. Okay, use the value of the diode. Balik kepada conditions lah. Kalau less than off, more than on. Tapi kita tak pakai the value. Once on, guna value Zener diode. Okay. Yes. Sebab kalau off sini tak ada, so bolehlah kira untuk KVL. Sebab the diode is off, macam mana kita nak pakai voltage diode? Okay, bila diode on, kita pakai voltage dia. Okay. Lepas tu once dah dapat that one, kiralah yang lain tu. Normally, bila these types of circuit, kita kena dapatkan, yang penting is nak dapat IZ.
Less than
Bukan IZM. Biasanya dia juga dibagi IZM. Because kat sini ada P, ada VZ. So mesti boleh dapat P equals to IB. Tapi that is IZM. So now we want to get IZ only. Okay. So the IZ yang last kali dapat berapa? 2.5. Okay. So that is the first condition. Ada soalan lagi? Faham tak? Dia confusing dekat yang 13 value tu kan? Okay. So once dah faham yang itu, okay. Can we go to the second one? Kena cepat sikit sebab kita ada 3 jenis. And then we have short quiz sekejap lagi. Alright. So this is the second condition. Once you kena faham the first condition dulu, because the second condition dia macam panjang sikit. Okay, anyone belum sign attendance? Okay, so the second condition still same circuit. Circuit dia sama je. For the second condition, we assume it is on. Boleh juga you kira it is either the diode on ataupun off. Okay. Alright. So now sama juga, we want to get the value of the VZ equals to VL. RL, the supply, the voltage divider lah, RL over RL over R total multiply with the V in ataupun V supply. Okay, now it is vary RL. So kita ada RL min and also we have the RL max. Okay, when we have the RL vary, the I current in the load resistor also we have min and max. Okay, so this is for RL min. The first one is we assume RL min R over V supply minus the VZ. This is R over VI minus VZ is VR multiply with the VZ equals to RL min. It is actually comes from the voltage divider formula juga. Okay, RL min. Sometimes bila you kira, kita tak tahu it is either min or max. Okay, if that case, you tulis je dulu RL equals to the value. Okay, nanti you get the another RL, so baru kita tahu, okay, this one is min, this one is max. Okay. Okay, once dah dapat tadi, we get the value of VL, dah ada, so we can get the value of IL next. Okay, this one, if you tengok, VL is equals to VZ, the given value. RL is from the value RL min tadi. If the RL is min, I is the max, because I equals to V over R. This one is kecil, this one is besar. Dia terbalik. Kalau yang ni kecil, yang tu akan besar, because this is inversely proportional. Okay. This is sama je macam tadi. Voltage at the resistor R. This is V in. Yang point selepas dia adalah VZ ataupun VL. So how to get the VR? V sebelum minus the V after. So this one lah. Okay. The voltage drop. VR is the voltage drop in between 2 point. Kan? We have point VI. The point yang selepas is the VZ. So to get the voltage drop, tolak lah antara dua tu. Okay, so that is for VR. And then once you get the VR, we can get the IR. IR is in the resistor. Okay, resistor depan tu. Okay, so VR over the resistor. And once we get the IR, tadi kita dah ada the value of the IL. So you can get the IZ. Okay, this one, for these types of vary the RL, the VI will be fixed and the IR also will be fixed value. Okay, this is to get on the IL mean. Dia kan macam ni. This is IR. Turun bawah is on the Zener IL. IZ. Goes to other side is IL. Here is R. Okay. If IL is kecil, katakanlah yang lalu dekat IL is kecil. Let's say if we have 10, kita bagi IL is 2. So maximum value akan lalu pass at the IZ. Okay, sebab tu kat sini IL min, IZM maximum. Okay, so katakanlah kalau IZ is the minimum, so IL akan lalu banyak. So dia akan terbalik. Okay, this one yang for RL max, because this one we vary the resistor, so dia akan jadi RL min, RL max. So for the RL max, VZ or VL sama je over the IL min. So dia kena terbalik lah, one max, one min. Okay. So we have one example here. Example of the second one. Fixed supply, vary the RL. We change the value kat sini. VZ change to 5. IZN change to 16. Okay, cuba buat. Yang lain sama. Okay. To determine the value of RL, we assume the diode to on. So first thing, we need to get the value of RL min using the voltage divider. Dia dapat kat sini what is the value when we change the voltage of VZ. What is the value you get here? Berapa? Aiman? Syed? 100? 111.11. Okay. So 111.11. Okay, katakanlah sekarang ni kita tak pasti min or max. Mungkin takut-takut yang kita kira the next one is smaller than 111. So you boleh tulis je dulu RL. Tinggal some space untuk you tulis nanti min or max. Okay. So 111.11 ohm. So next one you get the value of the VR. Okay. 50 minus 5 kan? Because VZ is 5, so dapat 45 VR. Once dah dapat the VR, you can get the value of the IR. IR will be fixed. So straight away IR 45 over 1K kan? Kita tak tukar the value of R. Okay. 45 over 1K. You dapat 45 milli kan? Okay. So next one kita nak kira the IL pula. Because kita dah ada IR and IZM. IZM is given. Kadang-kadang bila in the question, if it is not given IZM, dia akan bagi PZM. So sama je. So from the PZM, you can get the IZM. The maximum value allowed to flow in the Zener diode. Okay. So for that one, since dah lalu maximum, we assume to be lalu maximum at the Zener diode IZM. So IL yang lalu dekat resistor, load resistor, dia akan jadi minimum lah. Okay. Sebab remember dekat Zener diode dia ada certain range yang boleh lalu. So if we assume it is maximum, so yang lalu dekat the other components will be minimum. Okay. So this one dia akan jadi 45 minus 16 kan? 16. So you get berapa? 29 milli. Okay. Once dah dapat the 29 milli, now we want to get the second value of the RL. Okay. The second value, this is we assume minimum value to be flow in the load resistor. So the RL will be maximum. So voltage kita maintain yang tadi 5 over the IL min 29 milli. So you akan dapat berapa? 175. 172. Okay, so 172 ohm. Just now kita dapat berapa resistor? The RL. The first RL kita dapat berapa? 111. The second RL we get 172. So satu akan jadi minimum, the other will be maximum. Okay, so that's to determine lah. Kadang-kadang kalau kita tak yakin it is min ke max ni, so you just tulis je dulu. Once dah dapat the second value, so that will be the maximum. Okay, so this one lah. This is tak perlu lukis pun normally, just nak tunjuk kat sini. If it is minimum RL, it will be maximum I. Sebab dia terbalik. Maximum value resistor, minimum current. If it is maximum resistor, minimum current. Okay, so this is only the current that flow, the allowed current to flow. Okay, so this is, kalau soalan suruh cari power, then you cari je lah power. Okay, alright, so this is the second one. Okay, the second question. Ada soalan? Okay, ada soalan tak? Guys, untuk for the Zener diode, semalam saya tak ada bagi tahu. Previous semester tak ada. In the test. Previous semester kita tak masukkan on the Zener diode. So this semester might be ada on the Zener diode. Okay, 10 marks normally. Okay, it is either in these conditions lah. Kalau tak fix, dia akan pergi ke vary yang resistor, ataupun dia akan vary on the supply. Okay, we have another one on the supply. Boleh sambung? Okay, so the third case is supply vary, we fix on the load resistor. Okay, as compared dengan yang second case tadi, this one lagi pendek sikit, saya rasa lah. Okay, so sama juga, we use the concept of the voltage divider, RL over R total darab dengan V supply. Okay, and then from here we assume VI is the minimum value. So ni dia just pusing je the voltage divider, yang bawah pergi naik atas here, the RL duduk bawah. Okay, and then the maximum of the supply will get the minimum current. The maximum supply akan dapat maximum because V equals to IR. So dia dua-dua kalau maximum, both will be maximum kan? Okay, so that is why IR max kat sini. Sebab VI pun VI max. Okay, IZM plus the IL. Okay, for the VI max is the V supply equals VR plus VZ, or VR plus VL. Sama je. Okay, VZ equals to VL. And VR is equals to IR. Okay, I at the resistor darab dengan resistor value. Okay, tambah dengan VZ is the given. IR tadi yang this one. Okay, so this is for VI min, this is for VI max. Alright, so we have one example here, this one. Okay, so kita tukar the value for the R here, jadikan 250, VZ jadikan 25. Yang lain sama. R 250 ohm, VZ 25 watt. Okay, first get the value of VI min. We assume the VI is a minimum, comes from, tak perlu you nak hafal this formula sebenarnya, because this one is comes from the voltage divider. VZ equals to VL, sorry saya tulis VL lah. VL equals to RL over RL plus R darab dengan VI. Ataupun you boleh tulis VL equals to VZ, takut confuse. Okay, so use the value given lah, the VZ given. So since kita dah ada ada, ingatkan ada toyol apa lah kat situ. Dekat tengah-tengah malam dapat bunyi macam tu dah terkejut. Aduh. Okay. Iklan. Alright. So now bila kita tengok on this I put it in red box. Okay. VL is kita dah ada because VL dapat from the value VZ. R dah dapat. Now kita tak tahu VI. Kan? Because VI is vary. So kita tak tahu what value. So you use this formula to get the value of VI. Okay. Tu yang datang this formula, tak perlulah nak hafal. This is the same from voltage divider. Once you faham the voltage divider, insyaAllah boleh dapat lah this one. Okay, what is the value? Bukan ni 20
30.2
Okay, 30.2 volt. Okay, so the VI. If we not confident it is min or max, tak apa, you tulis je dulu. And then for the IL 25 kan? $20.83 milli ampere. Okay, so now you can get the value of the IR max. Okay, IZM is given. Normally dia akan bagi either IZM atau PZM lah. It is either, so boleh dapatkan the value. $80.83 Okay. Lepas tu next one carilah the VI max. This one IR. Yang tadi IR max darab dengan the resistor 250 plus with the VZ 25. So dapatlah berapa? 40 something 49 ke? Tok Zul dapat berapa? Sebelah Zul siapa nama? Fahim. Oh, Fahim. Okay, betul tak? 49 ke or 40 something?
Dapat
37. Okay. 37.78 volt. Sama? Girls dapat sama? Okay, for the course soalan on the Zener diode, normally dia kalau macam ni je. Okay, dia macam tak banyak sangat pusing-pusing. Very straightforward, but then it has three conditions. Yang mana satu tak keluar, yang tu tak keluar. Okay, soalan test pun belum set. Tapi I think macam menarik juga kalau masukkan on the Zener.
silap kami dengar.
Saya dah bagi key number dah ni. Sama tak 37
Silap madam, 42.
42. 45. Itulah saya rasa dapat 40 something. 45 45. Point 45. Genap. Point 1 2 5.2 watt. Okay, so tadi kita dapat 30, now 45. So tadi min, now max lah. Okay, if you not confident, one dah dapat both value, baru you tulis min or max. Okay, normally kalau untuk the third, this one, dia suruh cari ni je lah, min or max. Kalau dia nak juga I min or I max, then you kira lah balik. Because the value of resistor tu fixed. R is fixed 250, VI je kita ada 2. Okay, you boleh dapatkan the value lagi. Okay, alright. So that is for the third example. Saya nak tunjuk ada lagi satu. Ini tak ada apa, it just additional notes. You guys boleh tengok nanti on the formulas. Formula tu cuba jangan hafal, tapi you faham. Okay, because dia sebenarnya yang betul-betul you kena hafal ataupun faham is a voltage divider. Dia banyak apply voltage divider. I think for the KCL, you guys dah tahu dah pun, dah biasa. Okay, KCL or the KVL. Okay, so this is one example kat sini. This one is for fixed first conditions. Cara contoh soalan lah. Okay, I just want to show contoh soalan. I think dekat dalam tutorial pun ada. Okay, the first one is yes, the first thing is you need to determine the Zener diode is on or off. Normally akan ada markah lah on that part. Okay, but then for the second case yang vary tu, normally kita terus assume it is on. Tapi if you want to show the calculations yang awal tu pun boleh juga. Okay, so this is the first one, dapatkan the IL and then you get the I total ataupun IS, and then get the value of the Zener, IZ. After that, normally soalan dia akan suruh to determine it is either safe to be operate ataupun tak. Okay, so how to determine is, normally dekat dalam the Zener diode ni dia akan bagi, kalau dia tak bagi dekat sini, either dia bagi dekat dalam information soalan or it is given dekat dalam segmen-segmen soalan dia tu. Okay, as for here dia bagi the power. Once dia bagi the power, then you can get the IZM, because dia bagi PZM, you can get the IZM. Okay, so you get the value of IZM. Tapi just now you already have the value of IZ. So what you can do next is you compare. This is IZM is the maximum Zener diode current yang boleh flow. If it is more than IZM, meaning that it is not safe. So now kita dapat 44, IZM is 55. So it is less than. So you can conclude the Zener is safe. Okay, the Zener is safe or the current is allowed to flow. Adalah few sikit untuk justify the jawapan. Okay, and then contohnya kalau kita nak tukar the conditions, the question might ask might change the value of the supply ataupun dia change the value of the resistor value. Okay, and then you repeat the process again, kira dapatlah the IZ. Once you dapat the new IZ, the IZM, if it is maintain the same value, and then you can compare. 89 is more than 55. So you can conclude the Zener is not safe to be used ataupun not safe to be operate. Okay, the current is not allowed to flow. Okay, the Zener might be damaged. So apa-apa je lah. Okay, on the conclusions. Okay, so this is types of question yang boleh tanya lah. Alright, so this one is the first condition, the first case, fits for both. Okay, ada soalan tak on the this one, on the Zener? Dia macam panjang, tapi if you jawab flow by flow according the steps tu, dia tak adalah susah sangat sebenarnya. Okay, any question?
Dalam test dia bagi formula ke?
No.
Tak ada formula tu.
Formula kan dia, kan saya kata on the KVL you kena hafal ke kalau KVL ni konsep? Tak ada. Kan, depends on circuit. Kalau KCL pun sama, for the yang you macam kena hafal sikit, maybe voltage divider atau current divider. Kan? Yang tu je. Yang lain saya rasa tak ada kot. Okay, so this one pun sama lah. We are not giving the formula. Tapi yang macam banyak sikit formula is on the second case kan. Second case tu, yang the third case is voltage divider, simple je. Right, okay. Alright, so ada soalan? Semua faham?